So we can use the Pythagorean theorem to help us find an estimate for the length of line segments. So you can see I've drawn a line segment over here, and I'm not exactly sure what the length of this segment is yet, but what I can do here is kind of see that there is a right triangle that is formed where that line will act as the hypotenuse. So let me just draw in that triangle so you can kind of see what I'm talking about. So here it is. That's my right angle there. And I can measure this length here, 1, 2, 3, 4, 5. And this length here is 2. So I can now get a measurement for this using the Pythagorean theorem. So again, that's my longest side of that triangle across from the right angle, so that will be C. So setting up my Pythagorean theorem, I will have 5 squared plus 2 squared equals C squared. So 25 plus 4 equals C squared, or 29 will equal C squared. So the area of the square on that line here would be that square would be 29 units squared. The side length will be the square root. Square root 29. 29 is between 25 and 36, a little bit closer to 25. So I'll say that C is approximately 5.4. Okay, so that's how you would get a line segment if you're just looking for a missing line segment. Sometimes you'll be asked for the area of a square that looks like that. So if I'm looking for the area of a square, remember that when I do the Pythagorean theorem, just before that last step where I get the length of the line, I actually have the area of that square. So I'll show you how that works. So again, let's draw in our triangle. I'll draw it in here. I could have drawn it in anywhere. So this is my right angle, and I can see that this side is 3 and that side is 3. So the length of that line segment will be C, my hypotenuse, and the area of the square then is C, length times length, C times C, or C squared. So whenever I see C squared equal to a number, I'll know that I have the area of the square. So let's set up our Pythagorean theorem. So leg squared plus leg squared, 3 squared plus 3 squared will equal the hypotenuse squared. So 3 squared, 3 times 3 is 9. So I have 18 equal to C squared. So the area of the square is 18 units squared. The side length is going to be the square root of 18. Okay, so this here was the area of the square. And now I'm going to find an estimate. Would be 18 is between the perfect squares 16 and 25. So it's much closer to 16. A good estimate might be about 4.2. Okay, so that's how you can use the Pythagorean theorem to find the area of squares and the length of line segments on a coordinate grid. Thanks for listening.